improper integrals are integrals where one of the bounds of integration, or more, is an infinity or a negative infinity. Let's try to find the following integral. I'm going to start by finding the antiderivative, as I normally would. This is a u substitution problem because I can't do the division, and there's no quotient rule for antiderivatives. I'm going to try letting u equal the denominator, x squared minus x. That makes my du 2x minus 1 dx. If I solve for dx, I get du divided by 2x minus 1. Now when I do the substitution, I've got 4x minus 2 over u, and I replace the dx with du over 2x minus 1. We really want to be able to cancel out the x's, and if we factor a 2 out of the numerator, now we have a common factor of 2x minus 1. I can cancel those out, and I'm left with 2 over u du. The antiderivative of 2 over u is 2 natural log of u plus c, or if we write it in terms of x, 2 natural log of x squared minus x plus c. Now we have to deal with the bounds of integration. And technically we should be writing this as a limit so that we can then see what happens as that bound goes to negative infinity. However, in this particular class, I don't care if you do the problem formally by writing it as a limit. Instead, what you can do is treat it like another definite integral problem, like any other definite integral problem, and just plug those bounds of integration in. If we plug the negative 1 in for x, we end up getting 2 ln 2, and then we plug the negative infinity in for x. We're going to get, I forgot to write my ln in that second term, but I fixed it in the final answer. We should be getting, it should be 2 ln infinity. So basically we end up getting 2 ln 2 minus 2 ln infinity. And what is the natural log of infinity? Well, natural log is an increasing function. If you plug in a very large number, you also get a large number. So natural log of infinity is going to go to infinity. In fact, when you plug the infinities in, the only time they're going to converge to a number is if you're dividing by infinity. So 2 minus infinity gives us something that diverges. This is an integral that diverges. Again, I did this problem pretty casually. I didn't write down any limits. If you wanted to be formal, you'd have to change things into limits. But this technique of showing your work is perfectly fine for this class.